In section 4.2, you are going to be introduced to another way to solve a system of equations. Just a reminder from 4.1, a system of equations just means we have more than one, and you learned how to solve them by graphing. You graphed the two lines and you saw their intersection point. This section is how to do that algebraically. And it's called by substitution, and substitution just means to replace. So if we had the little example of x plus 7 equals 13, and you were told that x equals 6, then we would replace the x, we would substitute the x with what we are being told it is, which is 6. So then we'd have 6 plus 7 equals 13, which is mathematically correct. So that is what we're going to be doing. We're going to be replacing something for what we are told it is. So let's look at example 1a. We are given two equations, x equals y plus 6 and x plus y equals 10, and we are being told to use substitution, which means we are going to replace. And in this case, we are being told that x is equal to, which means x is y plus 6. Using our principles of substitution, that means we can replace any x we see with y plus 6. So we have our equation x plus y equals 10, and we were just told that x is equal to y plus 6. So now we substitute that, and instead of x in our equation, we have y plus 6, then we have plus y equals 10. Notice this is still the same equation, x plus y equals 10 plus y equals 10. The only thing that happened is we replaced x with what the problem told us x was equivalent to. And now we can work to solve this equation. And if we do so, we have y plus 6 plus y equals 10. That means there's two y's. We can combine those like terms. Plus 6 equals 10. If we solve that equation, we end up with 2y equals 4. If we divide by 2, we have now found that our y value equals 2. And when we were learning in the last section that we were solving a system, we had an answer that looked like an x comma y. It was an ordered pair on the graph. Well, we have just determined what the y value is. So in our answer, we know we're going to have some x value and some y value. Well, we know now that the y is 2. We don't know the x value, but we can find it using this initial equation that we were given. We were given the information that x is equal to y plus 6. So whatever the y is, add 6, and that's the x. We were just told that the y is 2. So we're going to replace that. And that's going to be x equals 2 plus 6, because the y is equivalent to 2. So notice we just substituted, replaced that. And now we have x equals 8. Which means the x value of our ordered pair is 8, and our answer is the ordered pair, the x comma y, of 8 comma 2. That is our intersection point, and we just use algebra to find that. Let's do another example. Here we are given two equations, which is a system when we have more than one, and we are being told that y is equal to 2x plus 1. That is y. Y is equal to 2x plus 1. And we're given the equation 2x plus 3y equals negative 7. If we wanted to solve this, we need to use substitution and replace something that they tell us. And in this case, they tell us what y is. It says y is 2x minus 1. So where I see a y, I want to put in this 2x minus 1. So let's write our equation. We have 2x plus 3, and now I want to replace that y. I no longer want the variable y. I want to replace it with what we were just told that y is, which is 2x minus 1. And now I have an equation that just has one variable in it, and I can solve this equation. Let's do these calculations. That's 2x plus, if we do 3 times 2x, that's 6x. 3 times negative 1 is minus 3, equals negative 7. Let's keep going. Combine these like terms. They both share a variable, so they're alike. That is 8x's minus 3 equals negative 7. If I want to get that variable alone, I need to add 3 to both sides and undo that subtraction. Bring down my 8x equals negative 7 plus 3 is negative 4. If I divide by 8, I can end up with x equals, and negative 4 divided by 8 is a fraction that reduces to negative 1/2. So in our answer, where we always have an x comma a y as an ordered pair, that is what our answer to a system of equations is always going to look like. If it has an intersection point, it will be an x comma y. The x is negative 1/2, and now we still don't know the y. But the equation that they gave us at the beginning was that y is equal to 2 times x minus 1. We now know what x is, so we can say y is equal to 2 times negative 1/2 minus 1. And 2 times negative 1/2 is negative 1 minus 1, which is negative 2. So the y value is negative 2, and our ordered pair is negative 1/2 comma negative 2. This is just another way to solve a system of equations. You can double check your work by using Desmos and still graphing both lines and seeing where they intersect. Look at example 3. Just like when we were learning in the first section that parallel lines have no solution, and that if both equations are one line, it has infinite solutions, you can see that algebraically as well. We can solve these systems of equations using substitution and see if they have infinitely many or no solution. So let's use our substitution. We have two equations here. We have x plus y equals negative 4, and we have the equation y equals negative x plus 5. So that means where I see a y, I want to replace that with negative x plus 5, and I still have the rest of my equation, which is x equals negative 4. Let's work to solve this. X minus x combines to be 0. There are no x's. And then we have plus 5 equals negative 4. So if we simplify that as 5 equals negative 4. Our variables have added to be 0 and gone away. And the only thing we are left with is the statement 5 is equivalent, is directly equal to negative 4. Think about that. Is 5 equal to negative 4? No. 5 does not equal negative 4. That is a false statement. And just like when we were learning back in the very first unit, if you have a statement that is false, that means that we have no solution. So these would look like two parallel lines on a graph, and when we substituted and solved algebraically, we could prove that there is no solution because it is a false statement. Let's try part B. Y equals negative 2x plus 5, and we have 2x plus y equals 5. We were just told that y is equivalent to negative 2x plus 5. So where I see a y, I want to replace that with negative 2x plus 5. And I'll bring down the rest of my equation. 2x equals 5. So I've done that replacement. This is now replacing the y. Let's solve this. 2x minus 2x. If I have 2x's and I take 2 away, those had to be 0. They're gone. And we end up with 5 equals 5. Now, is that a true statement? Is 5 perfectly equal to the number 5? Yes. That is a true statement. So, just like when we were learning back in the first unit, if we have a true statement, that means we have infinite solutions. So if we were to actually graph both of these lines, you would see that they're the exact same line, and therefore we have infinite solutions. This was section 4.2, which showed you how to solve a system of equations by using substitution.